This is Geo Kart, a Geometry Dash 3D recreation of Mario Kart made by me. Now this is what it looks like in the editor. Many people ask me to explain how all of this works and how it only uses 13,000 objects, so in this video I'll be doing just that. The first thing to understand is that the gameplay is actually controlled by a 2D top-down perspective. As you can see, the player controls a set of collision blocks constantly moving towards the direction the kart is facing. The other collision blocks make up the track. They are the walls, the power-up pads, the boost pads, and the mud. The 3D effect was created by placing a grid of track tiles in a 3D perspective. Through the use of careful layering and positioning, I was able to optimize this grid down to 2 objects per tile. An array of tiny collision blocks follow and rotate around the kart, acting as a sensor for this grid. You could imagine this array as the 3D camera field of view. Each one of these collision blocks has a unique ID and is linked to a corresponding tile on the grid, which also has a unique color ID. When the collision block detects a change of surface, such as road to grass, a collision trigger will activate a change of color for its tile, such as grey to green. This means that I needed a lot of collision triggers for each of the colors and each of the collision blocks. This is a slightly different 3D effect compared to other 3D minigames such as Dim by Sputniks. It uses a grid of colors instead of methods like ray tracing, which use rays to tell how far away walls are from the player, but it does have a similar collision setup. The gameplay and control setup can be built fairly quickly. I'll show you the basics of how it works. The setup consists of a kart collision block and a direction collision block. The player controls the rotation of this direction block. When holding left, it turns anti-clockwise around the kart, and when holding right, it turns clockwise around the kart. As for the movement, the center group of the kart moves targeted to the direction block group. This targeted move trigger is repeatedly activated by an infinite spawn loop, so that the kart is always moving towards a direction block. As for the wall collisions, these are a bit more complicated. It uses some wall detection collision blocks on each side of the kart so that it can detect what side of the kart is touching a wall. Using these new blocks, it will turn off the horizontal movement when touching a left or right wall, or will turn off vertical movement when touching an above or below wall. However, this method can lead to the kart getting stuck on walls, so we also need some more triggers that move the player away from the wall after they stop rotating. I'm not going to go too in depth into the specific details of how to make this yourself, as I already have a minigame tutorial that covers it. While driving around the courses, I wanted to add a minimap so that it would be easier to tell which way to go. After I created the collision block layout for a track, I copy-pasted it and scaled it to a minimap size. This made it a lot easier to draw the track design, as it gave me an accurate outline to work with. Once the track art was finished, the next thing to do was to add a marker for the player. However, this proved to be a rather difficult thing to add, as movements and follows start getting buggy on such a small scale. This was an issue as it meant the marker was often out of sync with the actual player position and would sometimes even go off the track. In the end, what I had to do was add some collision blocks around the track to correct the marker's position if it goes too off sync. The marker moves in the exact same way as the kart does. It is a copy of the kart's collision blocks, but scaled down for the minimap size. As an extra precaution, if the marker kept on going off sync, it would switch to a different movement based on the camera movements, which was less accurate but better synced. As with most GD bugs, there was a workaround this time, and the final minimap was so accurate that most players can't tell there was an issue. To make it feel more like Mario Kart, I needed some fun power-ups. In the end, I used Mushroom, Star and Gold Mushroom, as most Mario Kart power-ups would be useless with no opponents. When the player drives over a rainbow power-up tile, they are given a random power-up that they can use by holding both sides. The randomization is pretty simple. Each power-up was linked to a number between 1 and 3 in a counter. This counter was constantly looping between 1 to 3 by an infinite spawn loop activating a pickup trigger, and a count trigger to reset the value to 1 when it went too high. When a power-up is collected, a few seconds later, it would stop the counter loop, remaining on this power-up until the player uses it. For the controls, the power-up is activated by holding both sides. This is done by another counter. This counter increases by 1 when the player is holding down and decreases when they release. Therefore, when it reaches 2, the player must be holding down both sides, and a count trigger would activate the power-up. The speed boost uses a second direction block. This one is further away than the one used by default. When the player boosts their speed, the target move triggers change the target the further away direction block, moving a greater distance in the same time, hence causing a speed increase. This trick was used for all 3 power-ups and the boost pads. The mud slowdown works similarly, but with a third direction pointer closer to the player to reduce their speed. In this level, I wanted a background that moves when the camera does to make the 3D effect more believable. To do this, I set the background to move left when the camera turns left, or right when it turns right. Each layer of the background moves with different speeds to give a sense of depth. The closer layers move faster, and the further in the distance layers move slower. And through the use of careful move easings, the background moves smoothly in a more natural way. As for how the background appears to be infinite, this was made by looping the same background. Each layer was copy-pasted to the left and the right. When the layer moves too far to left or right, it will instantly move back to the center. As the center is the exact same on both sides, when lined up correctly, you can't even tell that the background looped. An easy way to think of this technique is infinite GIFs. These GIFs are designed so they loop at a point where the end of the GIF matches exactly to the start of the GIF. And with this technique, both ends of the background loop at a point where the end of the background is the exact same as the center of the background. And that just about sums it up. All of these techniques used together help to create a GD version of Mario Kart. I did initially want to add other opponents to race against, but unfortunately I was limited by the 1000 group limit and it would have made it a lot laggier. And thank you to everyone who supported this level in the GD Awards last year. If you have any other questions about how this was created, feel free to comment below and I'll try my best to explain. Special thanks to SR3K.